Good morning, students. Welcome to the online class of the Strength of Materials subject. In this lecture, we will be studying what is a Hooke's law, the Poisson's ratio, thermal stress, and factor of safety. The first, Hooke's law. So this is the stress strain diagram for a material. The stress strain diagram will be of the form as shown in the figure. So this is the stress strain diagram. In the y-axis you are having stress, and in the x-axis you are having the strain. So initially what happens is you will be having a linear region. So this part. So in this region you are having a straight line. So ZOA. So this region is called as a linear region. So in the linear region, the stress is proportional to strain. Since it is a straight line, we all know that the equation of a straight line is y is equal to mx, or y is directly proportional to x. So this is the equation of a straight line passing through an origin. For this diagram, that is the stress strain diagram, this curve passes through the origin and it is a straight line from O to A. So I can consider this as a line. So what is the y coordinate here? The y coordinate here is stress, and the x coordinate is strain. I can say the stress is directly proportional to strain. So to remove the proportionality constant, I am inserting a term Young's modulus. So the stress is equal to Young's modulus into strain. This capital E is the Young's modulus. Young's modulus, or you can say it by the term modulus of elasticity. Now we have to arrive at the dimensions or the unit of Young's modulus. Stress is equal to the product of Young's modulus and strain. What is the unit of stress? Stress is given by force by area. So force is Newton and the area is meter square. So stress unit is Newton per meter square. You have to find what is the unit of Young's modulus. So you let the Young's modulus E as it is, and the unit of the strain is
no unit, sir.
No unit. So I can say the unit of Young's modulus is Newton per meter square. Once again I am repeating, stress is the product of Young's modulus and strain. The unit of stress is Newton per meter square. I have to find what is the unit of Young's modulus. You keep Young's modulus as it is. Strain has no unit, so you leave it. So in the left hand side I am having Newton per meter square, and on the right hand side I am only having a term E which is having the units. So Young's modulus is only having unit, and this strain has no unit. So you can equate the units on both sides. So finally we'll be getting Young's modulus, will be having the unit Newton per meter square. Similarly, I can write when a body is subjected to shear force, shear stress will be acting. So that shear stress will be proportional to shear strain. So this is shear stress and this is shear strain. To remove the proportionality constant, I am inserting a term called as G. This G is the modulus of rigidity. Next topic, Poisson's ratio. So before understanding the Poisson's ratio, we should know what is lateral strain. Consider a body like this, and I'm applying a force, a tensile force, like this. So what happens is, there are two directions. One is X, another Y. If you consider a 2D diagram, there will be two directions, and if I'm considering three dimensions, means I'll be having X, Y, and Z. So you're applying the force P in the X direction. So in the X direction, what happens? See, there are three dimensions, X, Y, Z. So in the X direction, I'm applying the force P. So if you apply the force P, what happens to the dimensions in the X direction? The length increases. That is, the dimension or the length increases in the X direction. Now what happens to the Y and Z direction? So in the Y direction, let me show you by the diagram. You have a rectangular body subjected to a tensile force. So three directions are there. One is X, another is the Y, and another one is Z. So this is your Y and this is your Z. So three directions are there, X, Y, and Z. In the X direction, the force P is applied and the length of the bar. So if you take this length as L, on the application of the force P, what happens is it gets elongated by some amount. You take this as delta L. So what happens to the length? The length increases. In the Y direction and Z direction, due to the application of this force, what happens? What happens is this dimension. Suppose you take this dimension as B and this as D. So the value of B decreases and value of D decreases. So in which direction you are applying in the tensile force, the length increases, and in the directions perpendicular to the direction of applied force, that is in the Y direction and Z direction, the dimension of the body will be decreasing. So I'm applying the force P in the X direction. So in the X direction, there is an increase in length by an amount delta L. In all the directions, that is in Y direction and in the Z direction, I will be having a decrease in the dimension of the body. So the breadth decreases and the height D, that also decreases. Longitudinal strain and lateral strain. This longitudinal strain you have studied in the previous lectures. So this longitudinal strain is the ratio of change in length to the original length. So this change in length and the original length are taken in the direction of applied force. So due to the application of the force P, there is a change in dimension in directions which is perpendicular to the direction of the applied force. So this lateral strain, I can define the lateral strain as change in the dimensions of the body at right angles to the direction of the applied force. That is delta D by D or delta B by B. So if the longitudinal strain, consider this case, if you are applying a tensile force, the delta L value increases. So if longitudinal strain is taken as a positive, the lateral strain will be taken as a negative one. Understand? So these two are opposite to each other. If there is an increase in length in one direction, there will be a decrease in the length in another direction. So if you take longitudinal strain as a positive, the lateral strain will be a negative one. So I can define lateral strain as the strain in longitudinal direction causes a strain in perpendicular direction So this strain is called as the lateral or secondary or transverse strain. I can say it by lateral, transverse or secondary strain. The strain in longitudinal direction causes a strain in perpendicular direction, which is known as lateral or transverse or secondary strain. So this is how lateral strain is defined. Now coming to Poisson's ratio. Poisson's ratio, it is the negative ratio of lateral strain and a longitudinal strain. So why I am putting a negative here? Because this lateral strain and longitudinal strain will be of different signs. If I take the longitudinal strain as positive, your lateral strain will be negative. So the overall ratio, lateral strain by longitudinal strain, will be definitely a negative one. So if you multiply this term with a negative sign, what happens? You'll be getting a positive term. Since it is a ratio, to get a positive quantity, I am multiplying by minus sign. So minus into minus plus, you'll be having some value. So Poisson's ratio, it is denoted by the symbol nu or mu or 1 by m. You can write Poisson's ratio as either nu or mu or 1 by m. So this Poisson's ratio for all the materials will be in the range of 0 to 0.5. So Poisson's ratio nu or mu is given by minus of lateral strain by linear strain. The next topic is thermal stress. So we have seen what is Hooke's law, Poisson's ratio, and next is the thermal stress.